Elon Musk just filed plans to launch 1 million satellites, not for internet, for data centers in space, and he is not alone. Jeff Bezos, Sam Altman, Google, and China are all racing to build the same thing: orbital data centers that process AI in space instead of on Earth. In January, SpaceX filed an application requesting approval to launch up to 1 million satellites that would operate as orbital data centers. These satellites would process AI workloads in space, communicate with each other using lasers, and beam results back to Earth through Starlink. Blue Origin announced TerraWave, a constellation of 5,400 satellites for data center networking. China announced plans for 200,000 satellites focused on secure in-orbit data processing, and StarCloud became the first company to train an AI model in space in 2025. So why are all these companies suddenly racing to put data centers in space? The answer is simple: power. AI is consuming staggering amounts of electricity. Training a single large language model can require as much power as a small city uses in a year, and demand is accelerating. By some estimates, global electricity demand for AI could outpace what we can generate on Earth within the next decade. Space solves that problem. In space, solar panels work at nearly 100% efficiency. No clouds, no weather, no night. In the right orbit, satellites can collect sunlight almost continuously. And unlike Earth, where you need miles of transmission lines, in space the power is generated exactly where it is needed. There is also no need for water cooling. Space is a natural radiator. You can dissipate heat directly into the vacuum through thermal radiation panels, and there is unlimited room. Low Earth orbit is vast. You can spread satellites across thousands of cubic kilometers without worrying about zoning laws or environmental permits. Jeff Bezos said that within 20 years, giant gigawatt data centers in space will beat terrestrial costs. Sam Altman called space data centers the long-term solution. Even former Google CEO Eric Schmidt acquired a rocket manufacturer specifically for orbital data centers. But here is the catch: this is incredibly hard. First, heat. Data centers generate enormous amounts of heat. A several hundred megawatt data center would need radiators thousands of times larger than what the International Space Station uses. Building and launching radiators that large has never been done. Then radiation. Space is full of high-energy particles that corrupt data and cause errors. Every satellite needs to be radiation hardened, adding weight, cost, and complexity. Then maintenance. On Earth, when a GPU dies, a technician swaps it out in minutes. In space, a broken satellite just becomes junk. You cannot send repair crews 600 kilometers up. And then the environmental nightmare. There are currently 14,000 active satellites in orbit. Adding 1 million more would increase that by 6,800%. Astronomers warn that megaconstellations are already ruining observations. The Hubble Space Telescope could have 1/3 of its images contaminated. And when these satellites deorbit and burn up, the sheer volume of falling debris could kill one person every 2 years by 2035, according to FAA estimates. Plus, research suggests re-entering satellites could deposit far more aluminum into the upper atmosphere than natural meteoroids do. So will space data centers actually happen? The honest answer is maybe. The technology is not impossible. StarCloud has already proven you can run AI workloads in space. China has launched the first satellites for its computing constellation. SpaceX has the rockets and the ambition. But whether it makes economic sense, whether the environmental cost is acceptable, and whether regulators will allow millions of satellites to crowd Earth's orbit, those are still open questions. One thing is certain: the race to space is no longer just about exploration, it is about infrastructure, and in 2026, the battle for the future of AI is moving off the planet. Hi everyone, Mark here. If you are fascinated by the engineering of the future, subscribe and follow for more science, natural, and cosmic content.